Hello there. Talking about Newton's second law, we're just getting into the idea of force. Here we go. Force equals mass times acceleration. You know that, or the acceleration of an object is directly proportional to the force applied, the net force applied, and inversely proportional to the mass. That's what Newton wrote down in his Principia. But let's go ahead and talk about a problem. Here's our problem. Mr. Sokol and Mr. Herburger are having a tug of war. Mr. Sokol pulls with a force of 200 newtons. He's really trying hard. And Mr. Herburger, being a nice guy, the nice guy that he is, pulls with a force of negative 195 newtons. I say negative, 95. Sorry about that. 95 newtons, 95 newtons, because he wants Mr. Sokol to win, because it's for a physics class. What is the acceleration if the rope has a mass of half a kilogram? Okay, and so what do? We plug all the numbers in. Sokol's force here, Mr. Herburger's force here. We find the net force and divide by the mass. So the net force is 5 newtons, or 5 kilogram meters a second squared. I set it up this way because I want to be able to cancel some units so that I know what I end up with, right? So kilograms here cancels with kilograms here. What do I end up with? I end up with 10, right? 5 divided by a half is basically multiplying by 2, so 10 meters a second squared. The joke's on Mr. Herburger, though. Even though he's being so super nice, he doesn't realize that he's accelerating 10 meters a second squared. If Mr. Sokol keeps applying that force for over a couple of seconds, he's really going to start moving along pretty quickly. So that's it. Not a big deal. There it is. Mr. Sokol didn't pull that hard for that long because he didn't want Mr. Herburger to go flying. That would be rude. But that's it. There you go. That's a simple force problem. That is Newton's second law. Thanks for watching.